Voilà, record in the cloud. Hello, good afternoon. Hello again. After, I think, a break of something like almost, well, a month for sure. I think the last session was mid or end July. And then I took a break of myself of 3 weeks. And I had the ambition to start again immediately half of August, but that was clearly not realistic. There were so many things going on. And I decided anyhow to focus really hard on reviewing and updating the at your service documentation and making sure that the next session really goes deep into AYS. Because in all the things we do, especially in the context of ZeroS, AYS is important. It's quite important to understand. So what I will do today is basically go through AYS in the most comprehensive way I can possibly do at this moment. I'll show you, I'll do many demos on how to use AYS, both from the command prompt as from, let's say, the portal, the AYS portal. And I'll even show you what I also did in the other session, how to create your own AYS templates. In the other session, we already did create a very first Hello World AYS template for interacting with the orchestrator. I'm including also that part in the slides today, but I don't think I'll be covering that again today. That will probably be something I'll repeat in the next session. Anyhow, it's better to have a better understanding of AYS. And for those that are really new to AYS, I think this is most probably the best introduction you can get. So you don't need any pre-knowledge on AYS to understand what it is. What you will, most importantly, you will want to know, everything that I'll have been putting in the slides is also, of course, available in the documentation. And documentation, in our case, as you remember, is always on GitHub. In this case, AYS, as I will discuss in a moment, is part of JumpScale. And in the JumpScale organization at GitHub, you'll see the AYS 9 repository. And in the AYS 9 repository, the documentation is all in the master branch, and more specifically in the docs folder. In all the repositories, as you remember also for ZeroS, the orchestrator, and all the other components, documentation was always in the master branch. So everything that we'll be talking about is more, but with many more words and explanation and pictures also explained here. So just for your information, that is certainly something that you will want to check after the presentation. Okay, let's get started. Let's make the screen bigger. I hope it's not too big, because in my case, it's really a huge screen. So it's really readable for me, but maybe for some this screen is too big. We'll see anyway. So what we will cover is clearly AYS. I will make sure that you understand AYS as good as possible, that you really understand the why, the how, and the what, or the why, the what, and the how, in that, basically in that order. We will be using AYS against OpenV Cloud. OpenV Cloud is a very important component of the full solution. I'll make sure that you understand OpenV Cloud both from a ZeroS perspective, and that you also understand OpenV Cloud again from the perspective of what it typically can do for you, and most importantly, how you interact with it, both directly through the Cloud Broker portal, for instance, or through the end user portal of OpenV Cloud, but also through the APIs exposed by OpenV Cloud. So I'll show you the APIs and explain them to you. And I will then explain you how you can use these APIs, for instance, from within basically a Python interactive shell. This is important because, as you will see, we will be using blueprints, at your service blueprints, to also talk to OpenV Cloud. And I will then explain you and go a little bit deeper and show you indeed how these blueprints actually work, or how AYS actually works. And there you will discover that AYS is basically talking to the same APIs that I'll first introduce to you. And with that knowledge, it becomes quite easy to create an AYS template and basically get things done through simple blueprints, human readable blueprints, by declaratively specifying what you typically want to get done and have AYS do it for you. With this session, you'll have an insight and all the knowledge you need to create your own templates, specifically in this case to talk to OpenV Cloud. But of course, based on that knowledge, you could create a template for basically anything that you can think of. And I mean anything that exposes an API, let's say. Huh? Okay, this is the picture I shared already with you earlier today, just to attract people to attend the session. It is trying to give you also a perspective, a time perspective on what we did, what we will do today, and what we will be doing tomorrow, let's say. So in a way, the last session was what is on the left being shown as previous session. We showed you, and remember, at some point in time, we had an orchestrator running somewhere in 0S. Huh? And I showed you, and I'll do a repeat on that session as part of the next session. I showed you how you can interact with the orchestrator, not through insomnia, as we typically do, but really through an AYS service that I created for you, let's say in Hello World AYS service that I created for you, so that you could basically send the blueprint to the AYS server and have AYS server do the actual interaction with the orchestrator. So that part, I repeat, I'll do again in the next session, which will be quite easy to understand after you have gone through all the topics that I'll cover today. Because today, we'll create again an AYS template that allows you, top down in the middle of the screen, that allows you to send it to the AYS server. Yeah? AYS server will interpret whatever you specify declaratively in the blueprint, and AYS server will use that to interact with OpenV Cloud 2.1.7. Basically using the APIs exposed by OpenV Cloud. So we are talking here about 2.1.7. That is the actual version we have in production now with customers, which is still, remember, running on top of OpenV storage and is still running on top of an Ubuntu cluster. And remember, of course, this is all about 0S, this EAP program. And that's what we will do then in the next session. I'll show you how to run OpenV Cloud on top of a 0S cluster. And by the way, as promised, also the orchestrator will then run as a workload, as any other workload in a container on top of a 0S node in a 0S cluster. I promised you that going forward, we will get rid of the Docker containers, that we will switch to, well, the containers as we support them in a 0S cluster. And also, of course, the orchestrator, which until now always run in a Docker container, will then run, well, natively, basically, on top of a 0S node. For that, by the way, we'll, if you remember, and I'll introduce these concepts again in the next sessions, we'll introduce an F-list specifically for deploying an orchestrator, a container running the orchestrator. And that's where it becomes really interesting. Both for OpenV Cloud 3.0 and the orchestrator, will create an AYS template, meaning that you could use any AYS server somewhere in the field to basically not just deploy an orchestrator and on top of that the OpenV Cloud API in a 0OS cluster, but, and that's the main purpose of AYS server, making sure that the full lifecycle of the system, in this case, thus the orchestrator and also OpenV Cloud, is being monitored by this AYS server. And that when things go wrong, AYS server will also make sure, for instance, that a new OpenV Cloud instance gets created or that another orchestrator takes over in the cluster. So remember from what we all have been doing today, we always have been using a Docker container with jump scale. On top of this, or in this Docker container, we always have been installing the orchestrator quite manually, and that's what we did. In the next version, in the next session, you'll see that the orchestrator will be just like any other workload running in a 0S node, And deploying it can be done through the mechanisms we have been showing you already before, through scripts that well, simply deploy it. But it really gets nice when you can do it through the AYS server. And we'll make sure you understand that. Now, maybe the bad news, I don't know. For the demo today, I'll still be using Docker. Why will I be using Docker? Well, nothing related to the orchestrator, because we won't touch a lot of ZeroOS backend today, but because, as you will see, that the AYS server that we'll be using today will run in a Docker container on my machine. And I made sure, just as before, that every single step that you need to do to set up the exact same environment is documented, both in the slides and in the documentation that is available online in the GitHub repository. So that's important. And again, running in a Docker container today, but in the next session, I'll also switch to a ZeroOS container. So also the AYS server itself, and that's a little bit a chicken and egg story, of course, because you typically use an AYS server to deploy a ZeroOS cluster. Every single part of a ZeroOS cluster can be deployed through an AYS server, but you can use as many AYS servers as you want, because first of all, you see part of this installation of a stack includes an AYS server instance. But what we will be doing is that we will be using another AYS server to install AYS server. So that all is possible. And this AYS server will then run in a ZeroOS cluster. So this is the nice thing about, and that's where I always compare it with our brains. In our brains, we have like 85 billion neurons, cells, and they all work together in a very magic way. And there is no component or no neuron in our head that is in charge. There is not like one neuron that is central controlling everything. No, it's also a chicken and egg story. The neurons work together in some magical way. They form a whole, and that's exactly what we are trying to achieve here. We will be interacting with AYS server today through the RESTful API, but as you will see, everything goes through the RESTful API. So what we will be doing is using a command line tool and the RESTful API using curl commands. I could have chosen to do it with Insomnia too. Doesn't matter too much, but we'll focus most of the time do it from the command line, which is the most generic way, and it's the easiest way for you to learn and get acquainted with everything. Even if you would interact through a marketplace, a knee portal, as we will certainly show you in one of the next sessions, at the end of the day, it's exactly the same thing. It's the marketplace that sends blueprint to the AYS server to get things done. And that's everything that we'll be doing in the next few sessions. Okay, let's get started. As you might remember, in the last session, I used this concept of comparing AYS with a hamburger restaurant. I certainly invite you to check these slides because they are certainly interesting, especially to show them to non-technical people or to people that are not too technical. Salespeople, for instance, or pre-sales people that just want to have a first introduction to AYS. I'm not reusing these slides today. This time I'm really going to use really technical slides. So what is AYS? First of all, it's an abbreviation for at your service. Yeah, it is, and that is interesting. That is basically also something that I added only recently to the official documentation. It is an infrastructure as code type of application lifecycle management system. Yeah, infrastructure as code. I have a nice slide about that. I'll come back to it in a minute. But think of it as managing a cloud infrastructure in this context, and managing all the cloud applications as if it was code. So using techniques that typically are being used by developers, like version control and stuff like that, and use that to manage infrastructure and to manage the whole system. It's quite helpful if this is new to you, infrastructure as a code, to just check the article, the Wikipedia article about infrastructure as a code. It's a very good explanation that we'll find there. In its core, AYS is about lifecycle management. It's a system to manage the lifecycle of every single component of the whole system. And when I mean the whole system, I mean both the infrastructure, so the system, you might say, as well as any workload that runs on top of it. When I say cloud infrastructure, I even mean any cloud infrastructure. So, of course, we will most of the time do demos in using AYS to manage the infrastructure, the Zero-S infrastructure, or even in this case, as you will see, OpenV Cloud running on top of our legacy stack. It can all be managed through AYS. You could even manage, why not, an Azure environment or an OpenStack environment, would make more sense, I guess, to AYS if you want to. But more importantly, I think, it is typically this thing that you will be using to make the system intelligent, to make the system smart about everything running on top of the system. And when I mean smart, I mean that it goes beyond knowing how to deploy things by also being able to monitoring whatever you deploy and make sure that self-healing, self-scaling, auto-scaling, problems are being solved for you without any human interaction. So that's what we will talk about a lot today. AYS is the system that allows you to create such a thing, a self-healing system for managing the full life cycle of both infrastructure as the workloads. This slide is a slide that I also added only recently, just to try to explain you a little bit what it all does as a system. It's many things at the same time. It's a package management system, so it allows you to package any application, and typically an application today is a sophisticated thing, which is having multiple components that are not always very related with each other, but are needed to make the application run. And AYS allows you, and that's certainly some of the things that you will show you how you will do that, to create application packages. And once you have packaged your application, you can give then this package to AYS, and AYS will not only know how to install it, which is typically what is done through a package management system, but as you will see, it will allow you to manage the full lifecycle. It's a service management solution. What I mean service management, what I mean there is typically what you have, well, the scheduler of the services on the system. It's a system through which you can basically control, well, an application, a service, starting something, stopping something, restarting something. And especially in the more sophisticated workloads, where you have many components that are related to each other, where typically you need to start and stop things in the correct order, it's there where it becomes interesting as a service management system, that you don't need to know about the details and the order and the dependencies between the components, that you just say, you know what, stop the system and restart the system. And if there are many components that are involved that need to be started and stopped in a specific order, it's the job of AYS to know what to do in what order. It's also a scheduler. It's very related to the previous topic. A scheduler. When I mean with scheduler, think about you have a workload, and at a very high level, you say, you know what? This is my workload. This is the package to deploy it. AYS, deploy it, and figure out yourself where to deploy it and how many instances you need, and figure out whatever is needed to do. When things go wrong, when there is a big load, for instance, you might probably need another instance of one of the components. The scheduler is responsible to figure out where exactly deploy. And think again, brains, the 85 billion neurons, it's the scheduler that will talk to to whatever neuron, or in our case, Zero-S node that has nothing to do, or still has capacity available to take the job. So it's the scheduler also that does that. In a way, you could say, well, wasn't this the job of the orchestrator? Yes, that is the job of the orchestrator in a cluster. But think even at a higher level, at some point in time, you might be creating a big grid of multiple clusters. And then you can have like an AYS server that talks to multiple clusters and decides where to on which cluster it should run at a higher level. It's also, and on purpose I used the official term, the continuous configuration management, CCM, management tool for also automating all configuration. Typically, if you create an application, each application comes with its own configuration files and systems and so on. AYS allows you to, again, centralize everything using human-readable files, and that's also what it does for you, and make that central. It's also a monitoring tool, and the monitoring tool clearly is very related to the whole thing when we talk about self-healing. It's this thing that allows you to monitoring every component in the system, and based on whatever he sees happening, can take appropriate actions. And that's, again, part, of course, of the self or of the lifecycle management. Now, the core of AYS, of course, is a server. So there is a component which we call an AYS server. And as you can, well, think of, you typically have enough with one AYS server, but in a typical production environment, you might have AYS servers, multiple AYS servers, and AYS server that get spinned off on other nodes just to take over work from one AYS server and stuff like that. And so that's certainly also part of how we see it. It is installed as a component of JumpScale. JumpScale, remember, this is a thing that we have been working on for many years. This is the product that we originally sold from our previous company, Q Layer, to Sun Microsystems. And it's something that we have been using since then constantly, and it got evolved into what it is today. It's basically well, most of it is written in Python. It's a comprehensive library of all kinds of tools and components to make the life of us, to start with, developers and DevOps, easier when we talk about managing any component that you might think of in a data center. So it's a Python library. It's a very comprehensive Python library to do actually that. And AYS server, AYS, is part of that. So AYS server is the core of the system. And AYS server, how do you interact with it? No surprise, you interact with it through API, through a RESTful API. By the way, they ask me here, should I do that to choose a picture? Not sure what it is the moment. Anyway, I'll do that later. Oh, what do I do? No, I don't need that. Where is my screen now? Chat. Wait, my screen went away. Help. Let me go back to the slides. Where is my slides? Again, my slides disappeared. What do I miss here? Anyway, recent. Go back to the slides here. Not sure where my slides went to. They simply disappeared. Good. So you need the client, and interacting with AYS server at the end of the day occurs through RESTful API. As you can see, let me make again the screen bigger. As you can see, this RESTful API, you can talk to it from whatever Python client or any client. You could have a .NET client, you could have a Java client, whatever. It's a RESTful API, and we have just to make the life, of course, of the Python programmers here internally easier. We have also a nice Python client, but creating this client is quite easy because it's all based on RAML, R-A-M-L. So that is this thing that I introduced in one of my previous slides. It's this modeling language for modeling REST APIs. And we have even an open source project that allows you to take any RAML file and create an API for that in the language of choice. Today we will be focusing on using the REST API of AYS to the AYS command line tool. This is what we will do most of the time. And we'll also show you how to use the AYS portal. I'll even document it for you how to install it. And that's certainly also something I'll give you as an example. Now, at the end of the day, it's all about, on the bottom, and that's what I try to depict here, of managing the life cycle. And these arrows here is about managing the life cycle of any infrastructure and any of its application workloads. So that's what AYS Server does. Now, how does that work? You need what we call an AYS service for that. So each component or each application, or not on the slides, each whatever component of the infrastructure that you want to manage is represented by an AYS server. So an AYS server or service, sorry, is basically a proxy that is hosted in the AYS server, a proxy to the cloud application or any of its components that you need to manage. So it's some people might call it an agent. It's an agent living, in the AYS server that represents the workload or the component that it is managing for you. I don't like the word agent because agent is typically something that runs at the client side, at the side of the system. Proxy is maybe a better word, not reverse proxy, but proxy because it's really running in the server, but it's representing something running at the other side. Good. Now this picture I think shows it better. So each AYS service is being depicted here like this, and you might say bottom up or top down. You interact with the AYS server, and the AYS services on top are the ones that are exposed or that are being there to talk to. Some of them, you will interact with them directly, we'll talk about in a minute, and some others are like there under the covers, got spinned off by another AYS service. Yeah, you could call them like an helper or helper services that are not supposed to talk to directly by the outside world, but are typically created for being interacted with other AYS services. You get the point. You typically have AYS services that represent something. So this single AYS service here on the left could represent, this single thing could represent a full CRM application. And it's very possible that this AYS service needs the help, and better take one of these, needs the help of other AYS services that you don't need to bother about. And the idea is typically that when you talk about, for instance, a CRM application, clearly the CRM application it consists of easily maybe 20 different components that run somewhere in reality in the backend. It's very logical in such a situation that for every single component that makes up the CRM system, so a database, a few web servers, that for every single component you have an AYS service running or living in the AYS server, and that every single component is being monitored by a proxy. And of course, these proxies, they interact with each other internally, so that if something goes wrong at this level, that this AYS service can then talk to that AYS service so that he can do whatever is needed. Or when this AYS service feels there is something wrong, he knows because of the dependencies where the real problem is, he knows about the root cause, and he can then decide, you know what, we need a new AYS service representing being a proxy of a new instance of one of the components that we spin off through this new AYS service, or we use an existing AYS service to spin off, for instance, a new database, things like that. Huh? So that's what we try to depict here. So AYS services are really the things that represent what you are trying to manage. And you typically have one AYS service representing a whole application. And each AYS service typically will talk to sub or simple other AYS services to manage the distinct components of the system or the application you're managing. And that's just a way of depicting it. Yeah.
If one question, you mean that the AYS is also orchestrating other AYS services?
Yes, it is, because that's of course quite nice, because an AYS service itself also has a life cycle, which we'll introduce later. An AYS service also has a life cycle, and you know, it's quite important that if you have an AYS service representing one specific application, it's very possible that the AYS service itself goes down. Huh? Basically taking away all the management of the life cycle. So it makes sense that you have another AYS service monitoring the AYS service that is monitoring your system, so that the other AYS service, when it sees that the proxy that is managing the life cycle of the actual workload is going down, that the other watchdog, let's say AYS service, can spin off a new AYS service and takes over the work of the first AYS service. Clearly, the second AYS service that is like a watchdog should run on another AYS server. See, so I could have depicted that too, that you might have another AYS server hosting other AYS services, and think of it, if you would create an installation package for an application, as part of the installation code, the code that is actually being executed when the installation takes place, it's very possible that you spin off like an AYS service on another AYS server just to monitor the monitor. Eh? See what I try to explain? So that's the concept that we make possible through AYS. Right. Does this answer your question? Because I talk too much, I think.
Then in the AYS you got a monitor feature.
Yeah.
All right. Okay.
Yeah. Well, I'll show you how the monitoring works.
Yeah. Okay.
The monitoring. Yeah. I'll explain it in a minute.
Yeah, because I understand about the orchestration bits, but yeah, I also got the part about monitoring. But what actually trigger, you know,
yes,
because I guess the monitoring will create an event, and the event will be will trigger an action. Then that's the part.
I will explain that. Good question.
Okay.
It's good that you asked this question, because that's exactly what I will clarify, and that brings us basically to the next session. This next point. First of all, let's talk about what is the purpose of an AYS service. What does it do? What is its actions? And there you have it, the third bullet. Huh? An AYS service does many things. Typically, it has it's responsible for installing the actual application. So think of, like, you might have an AYS service that is typically used to represent an orchestrator. Why not? An orchestrator, remember, it needs to be installed. So the AYS service representing your instance, your physical instance almost, your real instance of the orchestrator, knows how to install the orchestrator. He knows how to do that. He knows how to stop it. He knows how to start it. He knows how to restart it. And most importantly, he knows how to monitor that. And I'll show you what that means, then monitor. How does that work? There should be something recurring. I'll explain that. How does your AYS service do monitor? Well, that's actually the role of an AYS service. The AYS service representing the orchestrator needs to know and needs to have some logic to monitor the orchestrator. He knows how to do things like backup and restore, self-healing, auto-scaling, just to give examples. He knows how to kill the actual backend application, and that's just to make it very generic, he knows to do whatever is specific needed for your application. An AYS service can have any function, can do anything. Now, how is that done then? Now, we'll come to actions in a moment, but the question then is, okay, an AYS service knows how to monitor, knows to install. Okay, good. And how do we talk to this AYS service? Because it's there, but how do we interact with it? So we interact through a blueprint, which is a YAML file, a human readable document. I'll show it to you many times, that you send to the AYS server. And based on that blueprint, the AYS service knows to which AYS service you want to talk and what exactly you want the AYS service to do for you. So this is just, by the way, one example of having an AYS service do something for you. As you will see in a moment, you can also say to AYS service, you know what, that AYS service there, with that name, I want him to do this every 5 minutes. And there you have it. This brings us very close to your question about monitoring. You might say, you know, this AYS service representing an orchestrator, I'll first ask him, well, install the orchestrator for me. Okay, installed. Okay, thank you. And now, every 5 minutes or every 2 minutes, check this, this, and this. And based on that, do this, this, and this. That's the kind of stuff that you specify through blueprint. And I'll show examples. Now, an AYS blueprint, what is it actually? It is typically something. So first of all, the first bullet is about what, and the second is about, you would say, no, the first is about how, and the last is about what, or whatever. The blueprint is typically what you use to describe, for instance, the full application setup. So a full blueprint could describe in a few lines, and that's very important. The blueprint typically is very simple. In a few lines, through very simple attributes, you might describe your orchestrator, your CRM application, your social application, web application, your whatever, and you describe in a very human-readable way the full setup. Yeah, that might be an example of a blueprint. A blueprint typically is also something that you use to change something to the initial setup. So you might have created a blueprint that described the full application, and then also you say, I want to change something to it. And then you might say, okay, I resend the full blueprint. That's certainly also supported. But one of the nice things about AYS is that you can say, you know what? It's like a house. And remember, and you might say, you know, I want to change like a socket for the electricity because I need an extra one. You could say, well, we create a full new blueprint of the full house just because we would want to add a socket, which doesn't make sense, of course. We support that, but it doesn't make sense. We also allow you to say, you know what? You can send one single blueprint saying, well, I want to have an extra socket, or I want to change the location of one specific socket on a wall through one single blueprint. And that's the changes and the added. And then, probably the most important one, you can also specify actions. Actions is like, what do you want a specific AYS service to do? So for instance, if you have an AYS service that is responsible, as I said, to monitor and install and do the full lifecycle management of a specific workload or an orchestrator, you could say, well, AYS service, I know that you are checking every 5 minutes this and that. Check it now, because I want to know now. Or you know what? I know that you're intelligent about the number of servers you need to get this thing done. Anyhow, add an instance of that specific component. So an action is something that is exposed by an AYS service that you can call. And as you will see in my next slide, you can also schedule it for recurring execution. And that's a nice one. Or you could also specify, you know what, this action should get triggered automatically when this event happens. We'll talk about events later. So there's also something like an event handlers, recurring jobs, there are many things. Now, what the blueprint actually contains, so the top explanation about typically what you try to achieve, and the bottom is you then achieve it through what language. You typically talk about what in the blueprint. You typically talk about two things in the blueprint, about AYS services and about actions. You always say, it's this AYS service that needs to do this, or I need to have a new AYS service that I will have to do this. That's how it works. So everything in the first half of my screen is about what you try to achieve, and in the bottom is how do you achieve it? What language you talk? So for instance, the blueprint will contain a definition or something that you want to have changed to previously defined AYS service. And it typically includes actions that you want to schedule for execution. Yeah, I'll come back to the scheduling in a moment. Now, another definition, all these functions, monitoring, installing, stopping, starting, uninstalling, that's actually what you expose, or what we say implement in an action. An action is the actual job an AYS service can perform, as I already explained a little bit. And you get things done by scheduling execution of actions. So an AYS service can do things for you. And these things are being exposed and implemented through the actions. And to really have an AYS service do this thing, you need to schedule the execution of an action. Okay. Scheduling and execution of an action. How does that happen? You have three ways of doing this. Today we will focus on the last one. You can explicitly specify through blueprint that service needs to do this action. And of course that service needs to have implemented that action. And the action can have any name you can come up yourself. You can implement as many actions and name them as whatever name you want. But once it is there, you can send a blueprint to the AYS server hosting your AYS service to actually execute or schedule the execution of one of these actions. More advanced, but certainly quite important, are the two other ways of scheduling and execution. The first one is, as you might expect, you can schedule execution to recur. I'll show you how you do that later. You can also say, you know what, this action is to be executed automatically when this or that happens. And what I mean with this or that, it could be that you say, you know what, if that other AYS service does this, you need to do that. So you can create relationships. What happens is that you can say, in an AYS service, create an event. And then you say for another AYS service, you will be an event handler for that event. That's how it works. There is a whole concept of defining that, and that's all documented, and it's certainly also covered in the slide deck today. Okay, we have a lot to cover. Now, how do you create all that? So you have an AYS service that exposes actions that I can schedule to execute. But how are these the AYS services created? Now, an AYS service is created from a definition, from a template. And we call that, what's in the name? We call that an actor template. So today we will show you how you create an actor template, which is a definition of an actor. And that's quite strange. I'll explain that in the next slide. And an actor template is a template, the definition for an actor, and the actual AYS service is created based on the actor. So it's like a two-step model. It's quite strange if you hear this for the first time, but over time it will make more sense to you. It's not like a class for the programmers among you and an object, that an object gets instantiated from a class. In a way, yes, an AYS service is instantiated from an actor template, but in the way we implement it, there is a level in between them that we call an actor. And I'll make sure that you understand that. There are very good reasons why we do it like that, and it certainly doesn't make the things more complicated. I just know from my own experience, if you hear this for the first time, from a pure programming perspective, this really is hard to accept, but that's how it is. For the programmers among you, sometimes it helps to see, it's like the concept of a factory. So you have a factory, you have classes and the objects. You could look at it like that. You have a factory, and a factory is typically something that is exposing for you in a very simple way things that you can get done. The factory knows which class to use for that, and based on the classes, the actual objects get created. So for some of you that are programmers, you will be happy with this explanation because that's what it actually is. But anyway, here I try to explain it visually. It's not only the women that like pictures, but also the men, I think, that things become much more clear with pictures. That works, at least for me. What I show you here, and I'm including immediately the actual names of the files and the directories. Yeah? On the server, in our case, it will run in a Docker container, the same basically Docker container we have been using for creating the orchestrator before. We have basically two directories that we use. We have this main directory where the AYS system files live, and then we have, what I will explain you later, the repositories, the AYS repositories. Now, at the system level, we have what we call the global actor templates. So that's really basically where all the templates, the definitions of the AYS services exist. In order for an AYS server to know and to understand your blueprints, like a blueprint saying, I want to have this or that CRM application to be installed and monitored and so on, the AYS server needs to know about the CRM system. So he needs to have an actor template defining that service, that CRM application, for instance. And that is typically what you could put and typically will put in a global actor templates directory. And this is a very specific single directory on your system. Now, what you will see, and it's nicely documented in GitHub, is that then when you really instantiate a service, you just realize that this AYS service, all AYS services live in the system. But clearly, what you do not want to happen is that my AYS services can see your AYS services. So we have a concept of repositories to isolate basically a collection of AYS services that don't have anything to do with other AYS services. The way we typically use that, for instance, is for customers. We typically have per customer, we have a repository. And the customer one will never see the services or the AYS services of the other customer. So that's one of the ways to map the ID, the concept of a repository. Typically you use it for isolating what you have for one customer and what you have for another customer. Huh? Now, also at the level of an AYS repository, we have a directory with the name actor templates. Yeah. And you know what? It's exactly the same as what you have at the level of the system directory for the templates. It's actually the same kind of files. Actually, it can be empty. If it's empty, and in most cases it is empty, when you then send the blueprint to AYS, like, I want to have this service to get instantiated, he will check, is there a definition of what the guy wants from me at the repository level? No, there is not. Then he goes to the global actor templates directory and he gets it from there. Yeah, you could have it on both places. If it's there, he will get it from there. And that's why do we have this, by the way, and this explains immediately the idea, is that you can have local versions or different versions of the same template per customer, for instance, per repository. That's the idea. It's even possible to not, and in the demo I will be using, I will not have my template in the global directory. I will create it in the local directory of the repository. And in that case, well, he will never even look into the global one. He will always look in the local directory, and based on that, he will then create an actor. Now, this sub-level or this mid-level actor is, in a way, it's just a copy of, again, what is there. But the difference is that all AYS services that then get instantiated based on this definition will use this definition, meaning that while all these services are instantiated, do their job, you can still change the code in the templates directory. And when you then say, I want to have a new one, they will always be being instantiated from the actor version. You will see in the documentation that once you have finished your code here, you can update all the actors there, and then all the AYS services also get new versions. It's a model just to support version. Remember that, and you'll come to appreciate this model the better you understand it. So this is high level, but it's quite important to understand, especially because at the command prompt, you will see coming back this directory structure. So even if you don't know about the top level, you learn about actor templates, we'll create a template, and based on that, we'll create a service. Okay? And based on one template, you create one actor, and based on one actor, you can have multiple instances of the same service. I'll give you examples. Now, this slide is trying to explain a little bit the life cycle of a service. So it's a bit strange because a life cycle, you use a service to monitor the life cycle of an actual workload. For instance, that is running on a ZeroS cluster. But also the AYS service goes through a life cycle. The life cycle always starts, as already explained, by the creation of a template. You cannot instantiate an AYS service if there is no template for it. So we need to create a template. Going through the documentation, you will see that we have created templates for many things. And I will show them to you going along. But I'll also create one together with you today. Based on a template, you send then a blueprint to the system. You say, no, system, I want to have an AYS service based on that template. That's quite straightforward, isn't it? By doing so, the system will create an actor. So you know this level in between. And based on this actor, the service will get instantiated. And this is what happens by the system. And that's just by saying, here's the blueprint. And this blueprint talks about this instance. And by what we call execute the blueprint, through this step in between, the service gets instantiated. Once the service is instantiated, it might be that by definition, that service has an automatic recurring job to do without you intervening at all, and it starts doing its work. But later in its life cycle, you might send another blueprint specifying explicitly to execute a specific action implemented at the level of the template, so that the service does whatever you specifically ask him to do. And what does he typically do? He is managing an actual application, or he is talking to another service that in turn is also talking to one or yet another application. See? In the full life cycle, at some point in time, also the templates, the service itself needs to be more intelligent. Imagine that we have created a service for proxying a virtual machine, for instance. And at some point in time, we learned that for that specific application, it would be nice to add a very specific monitoring thing, whatever you can think of, to make the self-healing capabilities of the system, specifically for that workload, better. This would typically require for you to update the actor template with extra code, extra intelligence. So you'll update the template. When you update the template, you will explicitly say, and now for that repository, update all existing services using the new template. And that's what is happening then for you. It's quite straightforward. And at some point in time, you say, you know what, I don't need that service anymore. You just send another blueprint to delete it through blueprint, and that will then typically trigger all kinds of changes, and things will happen. Good. So this is a high-level way of, again, explaining how it works. Now, what is the autonomy of an actor template? And you will see it. The autonomy of an actor template, it's basically 3 files. It's quite straightforward, 3 files. It's a schema. In the schema, you define the attributes of the service. And typically, these attributes will be very easy to understand. They typically map one-to-one to how you look to that service. Like, if you think about the CRM application, because we always use CRM application now, it could be like that you specify upfront the number of users you expect for that CRM application. You say, well, I think we have a CRM number of users of 1,000 users, and I don't want to bother about how many servers and what kind of scheduling you need to do for that. I just know that tomorrow we'll have 1,000 users that will hit this CRM web application. Well, it's then based on that knowledge that the at your service will know how many servers and whatever component he needs to spin off. Yeah? So that would be an attribute of the service. The actions is basically a Python file where you implement all the things that the service needs to be able to do. And it's basically to all Python functions that you create. You'll see. And the config YAML, that's an interesting one. I have many slides about that too, and nice documentation. That's where you define relationships among AYS services. And that's, again, very important for making AYS intelligent. Because if you say, I have this AYS service representing a CRM application, most probably you will have other AYS servers that need to get spinned off in the AYS server to monitor every single component that is used in the CRM application. And this relationship thing is defined in the config file. Maybe a little bit unexpected, but it is not. It's very logical. Even in the config file, you can schedule recurring jobs. Remember in the lifecycle story that you could spin off an AYS service, and that's it. And the AYS service, once it's spinned off, he knows very well without asking what to do. Why? Because you scheduled as part of the configuration automatic recurring execution of some of its actions. The monitor action is certainly one of the examples. Another action could be registered as an event handler, like you say, but without any interaction, whenever you activate this service by executing a blueprint specifying the name of the service, it gets up. And he knows, well, this event and this event, when it happens, I know I need to react. In the config, you can do other things that I have also in the documentation and in the slides, but I won't discuss too much today. Okay, let me go through the 3 files, very simple. So this is the actor template schema. It's based on a CAP-PNP format, a CAP proto format. Again, check the Wikipedia article, check the official website. For the programmers among you, it is like JSON, but it's really binary. And the point, of course, it's all about speed, about fast execution, having the most powerful execution that you can think of, but well, powerful but fast, bloody fast. So we have chosen this format to describe the schema that we use, both for saying what we need to do, but also for all for the interactions. But you know what? At the level of the blueprint, that doesn't show. And as you can see, it's quite simple. We'll create one. Here you see the one for the VDC. So it defines the VDC attributes, like account name, location, stuff like that. And that's what you do. Good. This is then an example that I've been showing you, that I will show you today, by the way, of an actions file. So the second file that is part of a template. And that's actually where you implement the actions. This is an example, a very straightforward, simple example of an AYS service that can do only one thing. It's not a very intelligent service then. It's certainly not a self-healing service. It's a service that only knows how to install, in this case, a cloud space or a virtual data center. The code that you see there, we'll discuss. It's documented. It's an example of how you interact through the Python API, basically the REST API of Open vCloud. And again, the full example of the real VDC implementation, you'll find in the link below. Yeah. Here you see then the third file. So we have 3 files in template. It's the schema, the actions, and the last one is the configuration. In the configuration, remember, that's where you define the relationships. You define the recurring actions, documentation, long-running jobs, events, and timeouts. Today, we are only discussing relationships. Just so that you understand, because it's quite a powerful thing. Yeah. Now, relationships, you have 2 kinds of relationships. Well, in a way, you only have 1 kind of relationship and then a special case of this 1 kind of relationships. Yeah? Here you see a very real one. Don't get, well, it's not complicated. The first time you need to go over it. The relationship is what we call a producer-consumer relationship. And the example we show you here is a fictive example, is in the middle. It's the idea of having an SSH key, and you might have the green box is an AYS service, with the name my key and my key 2, my key 3, my key 4. It's almost like Mickey Mouse, but it's my key 1 and my key 2. Yeah. What I try to depict in the way we also do it in the way we visualize it in the AYS portal. Is the way we explain it is always the name of the template. It's an SSH key template, question mark, and then the actual name of the service. Yeah? So here you see 3 instances of an AYS service, all based on the same actor or actor template with this name. Yeah. Now, what is so specific about this thing here is that it is by definition in the configuration of the myxyz service that is based on this template, and the config file of this template is what you see here below, is saying, you know what, this service consumes, this is a relationship definition, consumes at least 3 and maximum 100 services of this type, and it's automatic. What does it say basically? Whenever you spin off this service, he will need and he will require at least 3, and here you see 4, at least 3 instances of that service. Now, what we show you here in the next slide makes it nicer. Here's a blueprint that does that explicitly. Even while the word auto is there, I'll discuss this in a moment, but even while the word auto is there, I still can decide in my blueprint that I will be very explicit about the names and the number of actual instances of the SSH key service that need to get started. Here I say, you know what? I need an instance, and that's how we do it in the blueprint, an instance of type actor XYZ, that's the name of the template, __ the name of the service, my XYZ, you see, my XYZ, and it does all kinds of properties, these attributes that are defined in the schema file. And one of the attributes is that we need a list of key names. And here I'm very specific, key 1, 2, 3, 4. I even take 1 more than really necessary. And then I have 4 definitions in the blueprint. I say I want to instantiate also key 1, key 2, 3, 4, all based on this template. And that's the name that I then reference there. See? Now, the nice thing about this is, next slide, and see the coloring, green becomes blue. Why is it? Because auto was equal to true, remember. You could also have sent a blueprint saying, you know what, I want my XYZ service that is based on this template, with these properties. That's the only thing I say to AYS. But because AYS sees in the definition of the template that it requires the existence of a producer of information, in this case an SSH key, at least 3, and because I'm not specifying any explicitly, he will create them automatically. Automatically also, he doesn't know how to name them, and he will give them whatever name he comes up with. And typically it's something with auto _ a number. Don't bother too much with it. That's how it works. Huh? So that is the producer-consumer relationship. And I'll give you a real example in a moment. It's already, you might understand this. Why is it so important? It's because the system then knows when things go wrong, he knows where to find the root cause of the problems. And imagine that for some reason an SSH key is not valid anymore. Well, this actor or this service will know, okay, then spin off another one. And I can do that automatically. And I can give it a name, whatever. That's what happens. Here you see an example of, because in the previous example, let me show you, there was like a relationship, always like this SSH key is used by one single actor. But it's very possible that you have two instances based on the same template, XYZ1 and XYZ2. And they have, of course, still the same configuration, but that you say, you know what, they use the same instances. That's very possible. That's what you see here. Again, I just specify my two XYZ1 and XYZ2 services. And because of the definition of the service, he knows, well, I can reuse the ones that I've been using for the first one. That's how it goes. Okay. Now, almost there. The other relationship is what you call a parent-child relationship. And remember this very good. Parent-child is a special case of the producer-consumer relationship. What I'm saying here is that every parent-child relationship automatically is also a producer-consumer relationship. But of course, not every producer and consumer has a parent-child relationship. And it's clearly on the slide. What is the difference? What is the extra thing, what is so special about the parent-child relationship is that there is a one-on-one relationship. So in this case, I'm showing you another version of the template that says, you know what, there is no minimum maximum. The minimum maximum defaults to 1, by the way, in that case. And it's automatically, and he knows that, you know, this SSH key in that case will not get being reused by the second template. He will create automatically another one that is not related. That's a parent-child relationship. Now, parent-child relationship, in a way, is only useful. The real use is about organizing stuff. And here you see an example. This is a real example, by the way. This is a real example of how it works. So this is an example of a virtual machine. So what you see here, again, the green ones are the ones that you typically explicitly specify in the blueprint. You say, I want to have two virtual machines, virtual machine 1 and virtual machine 2. And what you see here is multiple things. First of all, this virtual machine 1 and the virtual machine 2 are children to this VDC. So basically, these two virtual machines run as part of a cloud space or a VDC, as we call it, that we have given this name. Yeah, and you even see that this VDC is a child of another parent. So this is the hierarchy. There is a parent VDC farm. And VDC farm is blue because that's typically something you will not specify in a blueprint. It's something that gets created automatically. So even a parent could get created automatically if you want so. Don't bother too much about what VDC farm is. It's a thing that we created to logically group multiple virtual data centers, if you want so. What you also see here with the blue lines, so the blue lines show the pure producer-consumer relationships, is that this VDC here, in order to create a VDC, you require an account on a system, and you require a G8 where you can create it. And basically the account is related to the thing. But there is no parent-child relationship. That's a decision we made. There's no parent-child relationship. And the SSH keys, you see here, we only have one SSH key that gets created automatically and is being used at multiple levels. At the level of the VMs, and also at the level of something that again, you will learn about later, it's a service that represents the SSH service running in the VM. So see, you can have an AYS service for basically anything. Having an AYS service just for a key, you might not have think of it like this. Having an AYS service even for a service that's running inside the VM is just another very good example. This example is like the service responsible for running the SSH service in the VM is being installed, but is also being monitored by a service, an AYS service. So you might have a configuration say, what? Every 5 minutes, try the SSH connection to this VM. If it doesn't work anymore, something is clearly wrong. And you know the hierarchy, and you know then at a higher level to for instance, notify through triggers that something needs to happen, see? And because of the parent-child relationships, what you see here is that on disk in the AYS repository, you'll see the exact layout, same layout being copied there. So the VDC farm is like the parent of the VDC, and then the nodes, or the VDC is the parent of the two VM nodes, and then you see the service that is managing the SSH service in a VM is again a child. Huh? And you do that just for management reasons. There is no real value to AYS to know that. More importantly are the consumer-producer relationships. And remember that every single parent parent-child relationship is also a producer-consumer. What I mean is that the VDC is a producer to the VM, and the VM is a producer to the SSH. Clearly, you cannot create an SSH service if you don't have a VM. You cannot create a VM if you don't have a VDC. That's the logic. Huh? Yeah? Okay. Here you see again, I'm not going to iterate on it. It's very nice. This is the actual config files of the templates that are being used when you deploy VDC. That's how it looks like. And this is a correct, and it even includes, not in the slides, but pointers to other services, disk services, and which are not, and even account use. So even for account use, we have services. Yeah. Events, I'm not going to discuss it, just read it. It's a way for you to schedule events. I'm not going to explain it, it's quite straightforward. It's again something you put in the configuration where you say, if this event occurs, automatically you want to have execution of these actions. On all the services which have implemented these actions. That's even possible. You can even say, execute that action on all the services by not specifying the name of a service or even the type of a service. When I say type, I typically mean based on a specific template. Huh? Okay, a lot of theory, a lot of definitions. I had to go through this. I think it's important, but this enables us to do an actual demo. Huh? I'm not going to go through this, but go through it yourself. If you want to set up the demo environment yourself, this is really what you need to do. This is the high-level view, how to set up. Every single step is being documented in a separate file. So I really took my time. I've been working hard on all this. This is the documentation on how to set it up, step by step. And every single step, I have all created a slide. This one should recognize. Creating the GS9 environment is the same thing. It's this Docker thing that you need to install. Use the 911, not master, please. Use the 911. And starting next week, we'll switch to 913, but I will tell you. 911 is a stable one today. You could try to use master, but you'll get into a few problems. I know how to solve them, but stick to 911. And next week, we can always upgrade to 913. Yeah? For the rest, do whatever, exactly what is being specified there, it will work. You then will have to set up the server. Again, it's being explained in the documentation. This is a slide about it. You will want to do some configuration. It's explained there how you do it. It explains how to start it. Everything is there. Same thing for creating the keys. It's explained there. I'm not going to iterate over that now. I have a slide on it later. The point is that we use It's Europe Online, and It's Europe Online is this OAuth service that we have open sourced, and we use it at multiple levels. You remember the other time when introducing Orchestrator, we use it, for instance, to both protect the Orchestrator API and the AYS, internal AYS server API. We changed something, by the way, for the better. We use two different JWTs for the two levels. So you can really protect the internal AYS server with a completely different identity and JWT from the higher level orchestrator. What we see here is at a higher level yet, your AYS server, your own AYS server, you will also want to protect it through It's Europe Online. What that means is that in order for somebody to interact with the REST API of your AYS server, they will have to send along in the HTTP header a JSON web token. And it's been documented the steps you need to take to set that up. That's what this slide is about. This is an example how it looks like. I'm not going to explain, it's in the slides. Once you have set up the server, you can interact with it with the REST API. But remember my slide in the beginning, you can also interact with the server through the cockpit. And the cockpit is typically the name we use for the official name, the AYS portal. That's what you see here, two screenshots of how the AYS portal looks like. It's a very visual way of showing you templates, showing you the implementation of blueprints, showing you execution of actions. It's a nice looking, some of you might disagree, but it's a nice looking web application showing you the inner workings of AYS, allowing you basically to see all AYS services, allowing you to instantiate services, allowing you to send blueprints to a web interface. We won't be using it much today, but it's there. More screenshots of the same cockpit, and I should replace it. It's actually the AYS server API console. So the API exposed by the AYS server is also exposed through a very nice looking API console, which is part of the AYS server, and this is how it looks like. So it's very nice. It's not only nice looking, it's functional. So you can use it to interact with it through a web API. This one is nice looking, right? So again, how to set up. And again, the same point is also your AYS portal, you can protect it through It's Europe Online. So in a way, it's like the fifth level of security. At the level of the portal, you typically have people log in. And in order to log in, you typically require that people have an It's Europe Online identity and that they are a member of a specific organization as being created in It's Europe Online. And by being member of that specific organization, they can use the AYS portal. But it's not because they can use the AYS portal and that underneath there is a JWT related to their identity, that they can interact directly to the REST API. See? So we have multiple levels of security. It's nicely implemented. It makes things a little bit more complex, but it's nicely, very cleanly implemented. So also that level, you need to do some configuration, which I think is very nicely documented today. That is being shown on the slide on how to set it up and so on. Again, this is how you need to configure it. It's a lot of work, but it's logical. It makes sense. And at least security is not an afterthought. And that's what we show you here today. And I'm proud about it. So there is nothing wrong with this complexity. It's the best thing we could have done. And I'm proud about it. So have fun with that too. This is just a slide I added because I'm well aware that all this security comes with a little bit of complexity, but it's well thought out. And with this slide, I just try to explain that just already at the level of installing your own AYS server and make it secure, you typically will create 3 organizations. And for each of the organizations, there is some configuration to do, all documented. Now, that being said, and I did it in the right order, typically for a test environment, you will use one single organization, and the guys that are member of the AYS organization, the at your service organization 3, that can log in the portal, will typically also be able to use the RESTful API. That being said. Good. Now, as you will see in the demo, if you have all set that up, you will see the AYS server is running, and you will see the portal which is running, and you see really everything happening on the system through the Tmux windows. That's in the slides. Okay. Where are we? We have been talking a lot of time already, and we still are, again, at the first slide. Yeah. In the first slide, I showed you that we would do this today. Yeah. Interact with Open vCloud 2.1.7 through the Open vCloud REST API. Now, the Open vCloud REST API, what's the basic concept of it? It's simple. Just you need to get introduced to it. You typically have an hierarchy. In order to get things done, you need a connection with the system. And that's what we call an Open vCloud client. So when you interact with the REST API, but it's not really a REST API, but the API, the cloud API of Open vCloud, you will first of all create and have a client connection. Once you have a client connection, you need to specify an account. Yeah. Once you have an account, you can create a cloud space. Once you have created a cloud space, you can create a virtual machine. And you know what? Remember this logic that I showed you in the AYS services with parent and child and stuff like that? You see the same model going up, coming back here. Huh? Now let me show you the API like this. How does it look like? This is the API of exposed by one of our systems. Yeah. This is basically what we call the cloud broker portal. Only admins have access to this system. So this is a Open vCloud web interface for administrators, through which people can, let me show you, through which people can create accounts, create cloud spaces, do all kinds of stuff, interact with the system. So here you have a cloud space. In a cloud space, you typically have virtual machines. This is a Windows virtual machine, and so on. That's what you see. Now, while this API, while this cloud broker exposes this in a very easy to use interface for administrators, everything you see goes through an API. Yeah? And the API, you have all sets of APIs. The API that we are going to use is the cloud API. That's what I showed you. For every single aspect in the system, you have an API. A cloud space, you create a cloud space. Yeah? You create a cloud space, and a cloud space requires an account, requires a location. You will give it a name. You will specify who has access, and you will specify the number of IP addresses available and the maximum memory capacity. It's things like that. So, and all this is done through an API. It's not only documented here, you can really also use it and test it. So it's a fully functional web console, an API console, if you want, for testing the cloud APIs. Strictly speaking, this is not a REST API. This is a classic, non-RESTful compliant cloud API. We are not changing that, but clearly, for instance, the orchestrator API is a fully compliant REST API. I'm not going to discuss that, what's the difference, but it's just for your knowledge, and it's certainly not disadvantage. So this is the API. That's the one thing. You can play with it. It's all very fun. Some of you will want to do it. Go ahead if you have access to such thing. Now, in order then to use it, I didn't use it to anything, but what we will do now, we will use basically this API, but not directly. We will use it by creating blueprints, and that's where it really is getting fun. I'm not going to explain all this. There are some basics. So I have documentation for the AYS basics, documentation for using AYS for blueprints with Open vCloud. It's all nicely documented. Just take this, create a VDC, and then you'll see documentation on how to create. I'm proud about it. It's all documented. Everything is there that explains you what you need to do with links to all kinds of stuff on how to do it through APIs, through curl commands. It's all there for you to use. So it's well documented, I think. Now, what I will do, I will use it. I will really do a demo on it using the documentation. So here it is. Finally, this is your first, well, second, because you have already seen that, of course, as part of the installation of an orchestrator. Remember, in order to install an orchestrator, one of the very first things we had to do was execute a blueprint, the configuration blueprint, which would spin off a configuration service. We'll discuss that later, again, just for your recapitulation. But here, you see another blueprint, and this is an example blueprint for creating a virtual machine that I give it the name MyVM, the My Virtual Machine, And I'm saying, you know what? This virtual machine is of type node.ovc, and that's how we call it. That's the name of the template. And this VM should be created in the MyVDC. The MyVDC is basically defined here. The MyVDC is the name I gave to an instance of the VDC template. So the MyVDC is the name of, in this case, the AYS service. By design of this template, we could change that. You could create another version of this template. The VDC that will get created will also get the same name as the service. The same thing for the VM. You will see that the VM that will get created gets the same name as the AYS service, which is basically a proxy for the VM. Now the VM, remember, or the VDC, remember, is dependent on a producer, the client, and that's the client, and the client in itself is dependent on an account. And the client, as you can see, you specify the URL where the OpenV Cloud cluster or the G8 cluster lives. And for authentication, I'm using a JWT here. Now, I am doing this for security reasons, because in the typical examples, we tend to use username password. I promise to myself that I will stop using username passwords in demos, which makes sometimes my demos a little bit more complex, because I will also have to demo you how do I create a JWT, given that I have, for instance, an account on a specific system. I'll show that. Now, what is so nice about this blueprint, this is one single blueprint that does not only include the definition of what I get done, and by the way, this also includes that this VM should have a data disk with this name, my disk, and the my disk is based on this template, and I'm specifying that it should have 500 gigabytes of storage. It's a data disk of type D, and maximum IOPS is being kept on 2000 IOPS per second, so that you can control. So this is what we call a human-readable blueprint, defining what I want to have. I want a VM with one specific operating system, a boot disk of 20 gigs, and 1 megabyte. It's not big. And what is so special about it, it also includes immediately an actions section, and it is in the actions section that you typically specify which actions that need to get scheduled. What I'm saying here, that whenever this blueprint gets executed, it should schedule the execution of the install, which will actually do the actual VM creation. Now, what I will do in the demo now, and you need to have the JWTs. Now, remember again my story. First of all, if I want to talk with the AYS server, in order so that he executes my blueprint, I need to specify a JWT. It doesn't just take whomever JWT is being sent from whomever. So I will do that through the RESTful API. Well, I'll do it through the command line tool, which is basically a level on top of that. But then still again, I need to identify myself. And for that, I'm used here a very simple, easy to use AYS command line that specifically creates a token for me. And with the validity of 3000. That's important. I'll do that. But I need a second JWT that needs to be included in my blueprint. Remember, you saw it in the blueprint here. This one, these 4 stars, I need to fill it out with a real JWT. That JWT is a different one. It's a JWT related with my identity. So what I will do as a Online user, I will make sure that I have created an application key based on which I can then create a JWT. And just for completeness, it's a little bit more complex, but I think you will appreciate it there. I created this JWT through curl command. I could also have used the more easy to use AYS command to have the same result. But the AYS command line tool command, generate token, actually uses the same API that is being exposed, in this case, by the REST API exposed by It's Europe Online. Okay, a lot of blah blah to introduce all this. Let's do it. Huh? Okay, let's just do it. And I have a few things. So that's my environment. Okay. What I will do, just so that you are aware where in the system I am now, I'm going to do Ctrl+B+D. Voila. I'm going to exit this one too. This is my machine. This is my local machine, my Mac. The first thing I do, I log into it's a virtual. I log into a virtual machine that is running somewhere. This is an instance of a virtual machine running in our cloud, Open vCloud. Okay, this is my machine. On that machine, I created. Well, to be complete, people, this is a container running in a VM, just as the orchestrator container we have been using before. What I will do now, I will check all the tmux windows, and you will see, and that's what you will get end with yourself if you install it. You will end up with 3, not 4, but 3 windows, one for the AYS, one for the MongoDB, and one for the portal. We'll never discuss MongoDB, and you will end up in the AYS server. So what you see here, these are actual things that happen at a level of AYS server. And that's basically my way of interacting with it. So the first thing I do, and let me take some things to use for that. Because I want to interact with this AYS service, I need to have a JWT. I can do whatever I want. So let me show you. I go to this directory, that's directory, the Optvar cockpit. And the first thing I will typically do is create a repository. The way to do it through the command line is like this, AYS repo. And you say create, create like this, yeah. Then you specify the name of the repo, like demo1, right? And then you specify, and this, of course, is certainly not to do in good practice, specify a Git server, typically. It could be a repository on, and it typically is a repository you have been creating upfront in GitHub. And why would you do that? Sorry, I need to take my cable because I'm out of electricity. Sorry for that. Back. Yeah. So what you typically do is create this GitHub repository. And what's the use of that? Is everything you do in this repository for a certain customer, for instance, or just for your demo purposes, is getting recorded, backup, you might say, in the repository. The idea is that, imagine that this AYS server goes down. Well, nothing is lost because all the intelligence is in the Git repository. And you could spin off another AYS server, and you could say, you know what, that's where the repository is of this specific customer, and the other AYS server simply takes over. That's the idea. So there we go. We create a repository. And what does it say? AYS server repo. Yeah, of course, the G is like this. Put it here. Yeah. It's being created. Now I'm lucky, and I'm not going to do it just for the sake of it. He's not complaining about the JWT. Why? The JWT I got created before, but remember that typically in order to be able to interact with AYS server, you need to do this first. Huh? Make sure that you have and it's documented how to do that. I'm not putting it here. How you get this client ID and this secret. So you need to go to its URL and get created. Huh? Voilà. Good. That's the first thing. Now the next thing is what we do. We have created a repository. We go to demo in. So we have created a repository also on disk. Demo 1. And what is in demo 1? Well, nothing. There are two directories, actor templates, which is empty. And there is another one, a blueprint directory, which is empty. Huh? See? There is nothing in it. Two empty directories. Yeah? You might think, oh, then it's simple. I should have created this directory myself and would have. No, it should be git repository. So use the AYS command to create a repository, otherwise it won't work. Yeah? So what I will do, I'm not going to create a template right now because the template that I will use is really part of the system templates. Remember, there's a global actor templates directory and there is a local actors templates directory. I'm not going to touch for now the local actors templates directory. I'm going to create a blueprint that uses the templates from the global directory. The first thing I do, I create a blueprint. That is quite straightforward. I go to, I create a new blueprint. And I give it the name blueprint.yaml, whatever you give it, whatever name and extension, that's okay. What I will do, I'll copy basically my blueprint, this one, like this, copy it, copy, voila. Insert it here, yeah. And of course, this will not work because we have to specify the JWT. Now, JWT, let me take just here, another screen. Voila. What I will do, I've prepared it. I've created a client ID and a secret like this. This is based on my personal identity. I typically also specify a validity like this. And then I'll execute this command. Voila. Copy. It's in the documentation and echo JWT. I have a new JWT. This JWT is basically private, only valid for 60 minutes. And that's the one that I copy there. So what I do now, let's get rid of this one, put it here. My copy didn't work. Again, copy, put it here. Yeah, oh, you did do it twice now. Yeah, well, sorry for that. That's an annoying thing. Well, let me fix it differently. Let me fix it like this, sorry. All right, insert, and let me put it like this, JWT. You'll see what I do in a minute. Put it again, and then delete the other one. Voila. And delete these two lines, or one line. Well, I think I didn't make any mistake. No, I didn't delete too much now. I don't think so. Huh? So, okay, save it. Now, what I will do now, before well, let me do two things. First of all, I'm going to execute the blueprint. It's a very simple action. So I do this through the AYS command line tool. And the only thing you have to specify is AYS blueprint, like this. What this will do is basically create the AYS services. Yeah? Let me show you many things. So you could do like AYS service list. What will have happened now is that he created these services. See? He created services. These services, AYS services, live now in my AYS server. Huh? Now let me show you. Let me show you something more, which is important. if we go to, because otherwise the demo will not work, I'll go to this system here. I go to the account, my account, there it is. That's the one I created up front. In the my account, as you can see, I have been doing demos. What I will do, I click this one and I delete it because otherwise it will not work. I clean it up. That's the first thing I need to do. Clean it up, confirm. Yeah, okay. So he's now deleting basically this data center, this cloud space, or including all the virtual machines and so on. Yeah, this is all happening now. Yeah, it is finished. That's good. What we will do now, we go back here, and there is only one command to execute. That is AYS. And before I do it, I'll explain what happens. AYS run. AYS run. And I create a run, as we call it, and I want to follow the progress. Now, what this actually does, because by executing a blueprint, you are explaining to AYS what needs to be done. And one of the things that had to be done was this action install. Now, at the point of executing a blueprint, what you are actually doing is scheduling the execution. The actual execution only happens when you, what we call, start a run, which is basically a process that goes through all the services and checks for actions that have been scheduled. And here I'm doing this explicitly through the command line prompt. By doing so, let's do it. What will happen, he will check all AYS services. He will immediately see that there are some relationships between all these AYS services, meaning he should execute whatever needs to be done in a certain order. And this clearly is based on these configuration files that they declaratively specified all the relationships. And I say yes, what will actually happen now, you see it, he's creating the form, he's creating the key, the client, everything. He is creating an account, he did create a disk. He's currently now creating the VM. Here you see it happening. Here you see it going through. When I go at this level, I can see this too. This is the view that only the admins have, is that this new VDC just got created. Well, I'm waiting, yeah. He's a little bit slow now. Yeah, so we should see, let me do a refresh like this. Yeah, okay, but let me go back just to be sure that we saw it. So at the level of accounts, we go to my accounts. What you see at my account, we have now a new VDC instance that got deployed. I click on it, yeah. And this VDC currently has only one VM that is running, see? And at the level of the VM, we should also see that next to the boot disk, there is a data disk. Where is the data disk? There's the boot disk. So that's the only thing I'm a little bit surprised. I don't see the data disk. Did I forget to mention the data disk? It should be there. So normally I should also see the data disk here. So the point is, through this blueprint, I did do the installation now. That is what actually happened. Good. Let's go back to the slides. Good. So what happens? So here everything is documented. Remember that you need to have two JWTs. You need to execute AYS, do the create. What I didn't show you, but it's very nice. You could also have done this through REST API, meaning from Insomnia or from whatever client code that you write yourself. You could also have done it like this. This would work as good as well. And we have even a way for you to specify a callback URL. And I certainly recommend using request B for that if you want to do some tests. Create a callback endpoint, and then you can specify that endpoint as an extra parameter here. So that's certainly something I recommend. And why would you do that? Because as you have seen, creating a virtual machine is not something that goes fast. Well, it goes very fast with Open Cloud, at least faster than what you would get from Amazon, but it takes a while. So that's typically something that you do. You trigger, you say, here, Blueprint, I want a new VM, and call me back when it got created. Good? Now, in order to create your own blueprint, you need to understand what is really happening under the covers. And what I do here is show you how it works. So, and I could do it from anywhere. Let's do it from my local machine. And on my local machine, no, let's do it the same machine. Let's keep it simple. Now, on this machine, where this thing is running, you can always use the interactive shell like this. JumpScale 9 is the interactive shell. Let's call it, there it is. In the interactive shell, you have then access to all kinds of tools. There you have access to JumpScale. This thing that I've been talking about, this library thing, that's where you have everything in order to get things done. One of the things is that you have all kinds of clients to interact with all kinds of stuff. For instance, here you see a full list of things that you can interact with. In our case, I want to interact with Open Cloud. So basically, this is a Python client, which is part of the JumpScale framework that interacts, that provides you an easier interaction point for programming with the Open Cloud API. And then at that level, you'll see that I have access to all kinds of functions. Now, it's quite straightforward. Remember, you connect to an Open Cloud environment, an MGM, via the GET or the GET from service. Already remember, it's in documentation. The second one is what you use when creating a template. But for now, it's always nice to start using the simple one, the GET one. And if you do a question mark and an enter, you get like some kind of documentation explaining what you can pass as arguments. It's a little bit slow all of a sudden. But it should give you now the commands. What I want to do, because he will come out with some, did I do wrong? Yeah, of course, what I need to do like this, I guess this will otherwise, just if you want to have the documentation like this. Of course, if, like this, right? And then you see indeed all the arguments you can provide. So what I will do, I will typically specify arguments. Now again, here you specify the parameters and the JWT. What we will do to make it simple, we'll copy the JWT that I created. So we say JWT equals, I copy it from here like this, copy, make it simple, copy. And don't mix up the two JWTs. This is the JWT that represents my personal identity to interact with that system. It's only valid for the time that I set. And what I can do now, based on that, I can now basically use, as here in documentation, specify the system and specify basically the JWT. There we go. Okay. What I get now is a connection object, and of course I forgot something important. Is a connection object that allows me to interact with this thing. So CL dot, and I have a connection that allows me to see, like, show me for instance all the locations, and it shows you that this system only has one location here in Belgium. So this is a proof that my connection is correct. Why am I doing this? Because I'm doing this as an introduction to how you create basically a template. Because the actual code that you will be writing, let me see whether I have something ready for you. The actual code for then actually doing the interaction is that we will do now. So from here, everything that I did before, and you will believe me, I could now create a VM, create a client through the code. But actually what we will want to do is create our own blueprint, not the blueprint that we have been using from the global system, from the global templates. We want to create our own local template. And we want to create our own version of a template, of an actor template, as we call it, for creating a VDC, a simple one. And that's what I'm going to do now. In order to do so, what we will do is, and it's documented, so I'm skipping some slides to go immediately to what you need to do. We will create these 3 files. That's what you see. We create these 3 files, and that's actually all the comments that we will do. Let me just show you at the command line to make it really good. So I'm not going to complete this. It's in the documentation. Everything that I'm about to do now through code, you could do it interactively here, and that's how you would do it. So quit this thing here. Yeah, not quit. And what we do now, we go back to the server. Yeah, and I'll be creating, why not, in a new repository. Yeah, so I'll do a new create like this. Voila, let's do it demo 2, demo 2 or something, whatever. Create a new repo from scratch. Yes. We go to demo 2 and 2. And we go to the actor templates, right? What I will do, I'll make a dir for my new actor. Call it actor 1, right? And I'm going to create 3 files. Now, the first file is the schema file, this file. And it requires a unique identifier. Now, for that, you could install this KPNP Proto tool. And once installed, you will use this thing here to create an ID for you. So let's create ID like this and create an ID. So it's a unique ID. I'll need it. What I will do next, I'll copy this code here because that's actually the schema file I will create. So I create the template. So I say vim actor 1. You give it whatever name you want. No, not whatever name you want. You call it schema. Copy NP. That's the first file you need to create. Insert, copy it. Oh, this will not work, of course. What I need to enter now is this extra thing here. And let's copy it again. Copy the string. Voila, I need this one. Width is 0. Copy. And insert it here. Voila, that's it. So this schema, what I'm creating is a very simple version of the VDC template for creating a cloud space. And how does it work? I'm accepting a JWT. And this is again the same JWT before because AYS needs my JWT in order to impersonate my identity in order to talk to the system. Now, you could do it differently, but that's how I prefer to do it for demos. You specify a location and you specify the number of IP addresses you want to have. And the cloud space ID is there. It's not an input value, it's an output value. You could set it, but it won't be used during the installation. But once it's installed, you will see that it gets updated in the AYS service instance in the system. So this is fine. So this is the first file. The second file we need to do is the properties file, but that's really, really straightforward because this my version isn't having any recurring actions or relationships. It's a really simple one, not like the one that I've been using.
Yes? Excuse me, you're missing the last bracket at the end of the schema.
Ah, good. Yeah, good. You see, that's all these things that you don't see when talking, and I talk a lot. Thank you very much. That's very good. And I'm happy you're there because I know of you that you're really very focused on the details. And that's what is important. Otherwise, the errors really are. So what we do now, we do the config, which is quite straightforward. The config YAML. And see, I'm not even passing any documentation. You can indeed pass documentation here. To be honest, I've not yet discovered where it's being used, these documentation strings. That's something I still need to figure out, but it's there. And then probably the most important file is the actions. That's where you implement what the function is of this service. Yeah, it's a Python file. And well, that's a problem. I need to find the code of it. I've prepared it somewhere on my machine and remember my stuff here, what I had. I think it's this one. No. I have probably another AYS demo. Voila, there it is. Let's open with Atom, like this. Okay, I have it here. Let me copy it. Well, let me show it on the screen because otherwise it's yeah, you see. This is the code. And let me explain what it will do. So, first of all, I'm specifying that I'm using jump scale. Yeah. So this is the jump scale library. If I would not do that, you could not do this, but then you would have to create and write your own code to interact with the REST API, with plain Python code to interact with the REST API, which would work fine. And also have examples of that too. If you love the pain of doing that yourself, we support you. Now, how it works, there is an object model. I'm not going to discuss in full detail, but the basics are, again, quite straightforward. First of all, you specify, you get an object job in every install or in every action you implement. You have this job object through which we pass you all kinds of stuff. First of all, we pass to you the name of the service. So, yeah, this action is being called, and through the job object, you know which service it is. Through the service name, you get access to the data. And data is basically the access point to all your things that you pass through the blueprint, or whatever you want to change as part of the action so that the service is aware of it. Here, this is the equivalent of the line of code I wrote before. See? It's the same thing. Yeah? It is using the get thing here. Quite straightforward. Yeah? I'm using the same code. And then I have here, I could have done this. I didn't go as far as that. I'm going to specify an account. In this case, why not? We could use the same my account, because that's what I did in my demo. Specify the same my account. So through the connection with the system, I'm saying, get me the account. And by the way, just for information, if the account doesn't exist, it will create one for you. If you have rights to do so, based on your identity, based on your JWT. Once you have an account, you can create a space. If the space already exists, it will just give you back a pointer or a reference to the space. If it doesn't exist yet, so as is the case in our case, he will create it. He will create it from the name you specify. See, the name comes from name, service.model object, name. And then, well, that's the way I do it, because in my template, as you saw it, I didn't have a custom attribute for specifying the name. I could have added one, which is the case for location and public IP address. There I did specify. See, the same, you need to, that is done. Then you say, okay, this will basically create a VM. This will then this will then use the ID that once it's created and put in the model and save. That's very, very simple. Yeah? Now, let's use that. So let's copy this code. So very straightforward copy, like this. Oh, what did I do? Stupid things again. Yeah. So did I copy it? I did. Yeah, like this copy. Good. And we go back to the prompt. We put it here. Sorry. Voila, it's there. I'm not making mistakes, I hope. You see, I've hard-coded the account. I didn't provide or specify any attribute I could have that allows me to pass the account. This is a very demo kind of thing. Okay, that's it. So, voila, my template is ready. That's all I need to do. Now, what I do, I go back to the root of my repository. Yeah. And the next thing is I'm going to create a blueprint. So I go to the blueprints and I create my VDC, whatever, what the name will be, YAML. There we go. And we need to create a blueprint. Now, just so that it's easy again, I think, let's check just that I don't make mistakes. Atom. No, not this one. Where did I create this? Let's save. Did I config schema? Where is my other one? Stuff, AYS demo. I think I created a simple one. This one. Open with Atom. Oh no. Well, it's a simple one. I can create it myself. Eh? So it's simple. Let's create it. Eh? Go back to the tool here. So let's create it. So just make sure that I use the correct wording. I think I called it actor 1, right? Actor 1. That's the name of the directory. That's the name of the template. That's how it worked. Then I gave it the name, my VDC or my whatever special VDC, right? Okay, like this. And I had 2 arguments, I think. I had location. I don't remember, to be honest. I'm a little bit, let's just open it in the schema. So that we are all, so that we are really, really sure. Voila. So, that's the old one, if. Sorry. Where's my demo? Sorry, I'm a little bit confused. That's the schema, right? Okay, good. So let's go back here and let's use the schema. So we need to specify the JWT. So JWT, we'll do it in a minute. Yeah. We need to we don't need to space a cloud space because that's the ID that I get when the creation succeeded. So I specify a location, which is quite simple here. It's BE Gen 1, like this. And we specify a max num public IP. And I could specify, again, anything, specify 3. Right? The JWT, remember, we just take the same one here because this is the one that is representing my account and giving access to the my account, well, my user account to give access to the my account in the system. Okay, if I didn't do anything wrong, the only thing that I specify immediately is also I define an action or actions, and only one. And the action I call is action install. Now, I'm not going to do that, but just for information, you could also specify, well, not just any install, the install based on actor 1, you could do so. And not all the service, but only the service with the name my special, you could do that, huh? So you can always be very specific. Here we keep it simple. I'm saying, well, schedule, remember, it's not going to execute anything. He's just going to schedule the execution. Yeah? Good. That's it. I don't think I made any mistake. If I made, that's a pity. I save it. And again, I do the same thing. I do AYS blueprint. Or I could use Insomnia and talk to the AYS user interface or REST API and do it like that. So there we go, AYS blueprint. Okay. Can't execute this blueprint type actor 1. Well, let me check what did I do wrong. CD actor templates. Wait, else. Oh, of course, if I see what I did. I'm okay. CD 2. Wait. Yeah. LS actor templates. Okay, see what I did? I made a mistake. I, of course, need to copy these files in the actor directory. So I move everything in the actor templates action spy to the actor, yeah. So a bit this actor template to actor, right? Yeah, actions. Spy, like this. You see? Let me go to actor templates, yeah. And then also move the config to actor one and then config dot YAML. That's where you can make errors. It's YAML, yeah, YAML. And then also do the same for, yeah, I could have done this in one comment, of course. Do the same for the schema dot KPNP, right? And put it there. I always forget, should I specify the name normally? For those that love to do things at the command prompt. KPNP, I always forget, right? Should be fine now, right? ls actor1, right? It's okay. So if you want to execute AYS commands, always do it in the root of the repository. So I do again AYS blueprint. By the way, if I don't do anything, what you do, if you AYS service list, and there is nothing, there is nothing to list. So this repository doesn't have any service active. By executing AYS blueprint, you specify that you want AYS to check the blueprints directory and execute every single blueprint. If you would have multiple blueprints, you could specify a specific blueprint. You could, that's certainly also an option. And by the way, the same thing through the REST API, you could say execute everything you find in the blueprints directory, or you can say only that blueprint. So here I'm saying execute everything, there is only one, so it would be straightforward. Yeah. What did I forget? During execution, my service template not found, can't execute this blueprint. I made a mistake and I didn't see why. Because this time the actor is okay. So ls actor templates, actor one, actions, config, actions.py, config.yaml, schema.kpnp. What is wrong? Can't execute this blueprint, type input error. What do I do not? And then let me do a cat blueprint. And let me just check the blueprint. My VDC and actor1 underscore my special VDC JWT location maximum public IP actions. I don't see any mistake here, and I'm seeing something. I'm doing something wrong. Tips? Yes.
Yeah, very quick one. Maybe I haven't done this kind of templates, but don't you need to say to specify AYS blueprint and the name of the blueprint? I mean, the usual command is AYS blueprint and the blueprint name.
Yeah. So like because this.
Well, yeah. Otherwise, I will execute everything within the blueprint directory.
True. Yeah, but that should work. So even if I do, you will have the same.
No, I think you're going to have the same.
You'll have the same
error. Yeah, it's going to be the same. Yeah.
Result. So I'm service template actor not found. I'm doing something stupid. Let me check my own documentation here. So, by the way, here's the template action install. It was create. That's why. So then, yeah. Very strange. Config YAML. I created this one. What am I overlooking? Run, create, follow. Create schema, copy, PM. This is really annoying. Vim schema. I did that correctly. The config, everything is okay. So can do Vim actor templates actor1 correctly written config .yaml. So doc property all looks okay. Maximum public IP, and then the other one is schema PNP. The ID is okay.
Had you specified the cloud space ID?
No.
Because I
You
think
the blueprint.
you need to do it.
Think so? I think it's optional, but make me doubt.
Well, if you got admin permissions, I think it will work. Otherwise, it won't. You need to specify the cloud space ID.
I can specify, but of course it doesn't have any use to do so. 1, 2, 3.
No, but it's not error. It's not found. You can't find the template. Service template.
The only thing I can think of is, but that's not necessary, AYS actor. So help and I can do an update, see? You can, like this.
Yeah, it's actor update, yeah.
I can do an update, but I don't think it's necessary.
You shouldn't need it.
Normally I shouldn't be. And if I do it now, see, something is not going okay here. Service act not found, can't execute blueprint, raise exception, input BP valid.
It's the service template, you can't find it. Is the hierarchy correct?
Yeah. You mean the hierarchy in the directory?
Yeah, within the directory.
Yeah.
Inside of the actor templates. Yeah.
Yeah. Actor 1. No, so the actor. Action spy. Okay. So there is always something that needs to go wrong. And probably after the session, I will be able to tell you exactly what. So I have to come back on that one. Yeah? Anyhow, now what would have happened is that the VDC got deployed as before. What I also plan to do is show you like the let me show you anyway. I think that
if a quick one, maybe you need to have also the service directory created. I'm not sure it does it automatically. Only when you provision.
No, it should create it automatically.
It should do it automatically.
Yeah.
Okay.
Yeah. By the way, here you see the AYS portal because I wanted to show you that too. The AYS portal gives you access to the same information. So if I go to demo 1, I'll see the blueprints here. See? So there you see my blueprint. That's my blueprint. And even here, I don't see anything. G8 client. No, that's the other one. I need to go. What is the demo directory there was? Demo 2, of course. If I go to demo 2, repositories, and go to demo 2, well, it's not on the list. Demo 2. Demo 2? There is demo 2, see? And then you're going to go to the blueprints. There you see my blueprints. Actor 1. I'm still hoping to see something here. My special VDC, JWT, location, all good. Actions, action install. And also there, you'll see the actor templates. And that's the problem. He shows now the global actor templates. My actor 1 is not in the list. And that's a pity. So I was really hoping to see my actor 1 here, but it's not in the list for some reason that I don't get. Very annoying. But at least I'm showing you here the user interface. Normally, but I know how to fix it. It's a setting I forgot to do prior to the demo. You also have this AYS API here. And I need to fix something in the configuration so that this one renders like that. And that allows you to interact also with the AYS server, the REST API, I mean, through the user interface you saw in the screenshot. So, and this is typically what you recognize from the user interface we have for the orchestrator, where you then can list all the repositories, and this works quite nice also. So this is typically the bridge to what you know from using Insomnia against the orchestrator. You use typically then this to work against OpenV Cloud API. Now, a little bit to close the session, and I'll come back clearly on what went wrong. We want to know, I think, we all want to know. To close the session, let me finish here. So again, this is the old slide that I used the previous time. Remember that you typically have another AYS server to interact with orchestrator. In this case, I was using it to interact also with OpenV Cloud. That is what we will do later. But I used this slide the other time just to introduce, and it's in the slides, and I will redo the session as promised, that you can create your own template. And here I created a template which was a little bit more sophisticated. It is a template, and here you see the actions file for interacting with the orchestrator API. So at least you recognize things that are the same, like import GS9 from the jump scale. And we had here the API, the client for interacting with the orchestrator. Again, you see the service, the job object that we use, from which we know which service we are. And from the job object, then we can get all kinds of information. The only thing, but I'm not going to discuss this, but this one, I'm not going to go line by line, but this one is just going to use the REST API of the orchestrator to create a container. So if you have been using and learning and to work through Insomnia to interact with the orchestrator API, that's basically this code that you would put there. And remember what I said in the beginning, the state of a service, is typically, remember that, in AYS. And now you might start to understand. It is AYS that has the state. So if indeed a container goes down, you need to make sure that your service has all the logic and all the intelligence to make sure that the service, the actual workload, I mean, can spin off elsewhere and receives whatever state via the AYS service. Of course, that requires coding and putting intelligence at the level of the AYS service. So it doesn't come for free. The only thing that comes for free is the whole system that allows the structure, the framework that allows you to create these kind of things. Right? And the hello world, it again shows you the same thing. Create a repository. Now you can check whether I didn't do anything wrong. Go in the demo directory. Make a directory for the name demo. Wait here. Demo, template demo. Here I did do, but it was optional. I did create 3 files. I used demo. I don't see, because you see demo, I use correctly demo here. Install the Python client, which is not necessary in our case. This was also not necessary. Blueprint create, so I don't see what is wrong. So we see basically the same thing. The schema there was different. So there the schema was we specified the orchestrator IP, and we also passed the token, the JW token here, to get it done. And that's it. Huh? So also based on that documentation, I don't see what is wrong. So the config was even empty there. The action spy was actually this code. So, and yeah, I don't think I made a mistake there. Schema, copy and P, all right. So there is something that I'm missing that I don't see, and that's something to cover in the next session, of course, when we do more sophisticated sources. Now, to stop the session, again, it took much more time than foreseen. I broke my record, and sorry for that. I'm not that proud about it, because I'm really aiming for sessions like only 30 minutes. And clearly this is much too much for one session. So what we will cover in the next sections is, anyway, as promised, we will run the orchestrator natively on 0S. We haven't touched any orchestrator today, but going forward, when we touch orchestrators, we will make sure that you deploy them on a 0S node through an FList. And if you have understood everything today, you also should understand that it's even better to create not just an F-list for an orchestrator, but also create an AYS template for an orchestrator. And that one of the attributes, or not even one of the attributes, because the template should hard-code to know which F-list to use, but you would use AYS to know what to do and to know where to fetch the F-list. Then the same thing for Open Cloud. I have, and I will discuss the Open Cloud installation instructions. And again, you could install them on top of a Docker container running jump scale. That is what I can show you immediately. It's quite straightforward. It's already documented. You will find it easily. But again, it would make sense, much more sense, that we create an AYS template that just requires you to specify through a blueprint a few parameters like where, whatever, on what orchestrator I need to talk, and that you, through the orchestrator, the Open Cloud is installed in a container on top of a 0S node. Yeah, that's what we need to do. Very good point. One of the questions was we need to have insight on monitoring and health checks. I always postponed it for many reasons. One of the reasons is that that of course the whole monitoring health check requires AYS, and the better you understand AYS, the better you understand how monitoring health checks work. And also important to realize, for the real workloads, it will be you understanding your workloads and the system, how to implement the health checking and the self-healing and the actual monitoring. That's certainly something where we all together, not just us, but especially you, for the specific workloads, will want to do the actual work. And then also the AYS services is, again, just another example. The AYS server, I'm not putting it on the slide. It's actually a third bullet point I should add here. That also the AYS server. So let's put AYS server on 0S, because I'm running it also now on a Docker container. So all three components that are typically related should be running on 0S. And once that is done, of course, interacting with 0S to deploy whatever workload you want, you will do through an AYS server. So you create a template for that, just as the Hello World template that I just showed you on the slides. Voila, so we still have plenty of things to discuss. Apart from all that, we need to update you on the roadmap. That's certainly something that we need to do because we are very close to beta 1 now. So we are currently at alpha 8 and we plan to release beta 1 in October, beginning October, half October latest. So we are very close to release everything as a beta for general availability, let's say. The full plan is to release for release by the end of this year. So we certainly give ourselves a little bit more time than just a few months. We really want to release by the end the full package by the end of the year. But the first beta, which is quite feature complete on all levels, should be October timeframe, beginning October timeframe. But apart from that, we still also need to update you on what has changed. Because on the storage level, we have changed some stuff. We are not using any more RocksDB and stuff like that. Remember that. And I have to clarify all that too. You will see how it is. We have made some big changes there. But in general, the concepts are the same. So it's not a big change. Voila. Again, should I sorry myself? I don't know. I let that to you. About the time I took. It took much more time than foreseen, 2.5 hours. I will, as always, share the slides with you through the Telegram group, and I will upload the full recording for all of you and those that could not attend on YouTube. And of course, you can still ask questions if you want to, but I'm also available privately, of course. And I always appreciate that people ask questions in the group, so that not just I can answer, but also yourself could answer, and everybody can learn from each other. Voila, thank you very much. Questions? Nobody? Really? Okay, let's close the session. I think it took long enough. I certainly enjoyed it, as always. And I'm very eager now to find out what the problem was. And I will get you posted on that one as soon as possible. Thank you very much, ladies and gentlemen. Bye-bye.
Bye-bye.
We stopped recording, I guess. So that's also already one thing. Did we? No, we didn't.